It's just this.
Ah, okay. Continuing.
Ooh. This is the tail end of last question.
We're continuing iterated integrals and double integration over rectangles.
Are we still just order of operations left over?
In and out.
So you do the, okay. Yeah.
And so first it's integrated with respect to rho.
So I guess would it be wrong to put parentheses around what's being integrated? Like, could you do integral of 0 to pi over 2 parentheses?
That's exactly what it is. We just don't write it. What's 4 cubed? It's 4 to the 4th over 4.
4 cubed, 16, 16.
That's 4 to the 4th.
Oh, 4 cubed, 4, yeah.
It's 4 to the 4th over 4.
16 times, yes, it's 64. Look at that, I know things on vacation.
And that's 2 to the 4th, 16 over 4. Simplify this by factoring out the 84. Now we could use a calculator for this. But where's the fun in that? Yeah, but where's the fun in that? Let's do this by hand. I'm not going to do that, so factor out the 16. 4 times 16, we already know 16. 4. And if we integrate just 1, right, it's the length of the integral, pi over 2, times 4 is 2 pi. And I've got my d theta. So let's just look at this integral. How do we evaluate that by hand?
You can do cosine squared times cosine squared. You can just do it.
How would that help you?
You can just break it up into 4 individual cosines.
How would that help you?
Because you know what the integral of each cosine is, and you just do.
Okay, let's product, not a sum.
Oh, sure. You can't easily do stuff. I guess you would have to
Actually, you just can't do sub here.
Yeah, because there is another can.
Well, yeah, there's not another thing like chance out. There's 3 ways to do this.
Isn't it you?
There's 3 ways, but 2 of the ways are kind of the same. You could use the cosine reduction.
Yeah, I was gonna say you said what true, so.
And so you could use the cosine reduction formula, but that was derived using integration by parts.
Okay.
Right, so you could do integration. You could do the cosine reduction formula right off the bat. You could do integration by parts, which is essentially the reduction formula. Or you could just use trig identities.
Trig I've been using trigs for a day.
Now, trig sub is different. Trig sub is integrals involving the form of a square root, either x squared minus a squared, x squared plus a squared, or a squared minus x squared. Now use the reduction identity on cosine.
Okay.
1 plus cosine 2 theta all over 2. That is cosine squared. Expand it out. Now we have another cosine squared that we have to deal with, which is this reduction identity again. 1 plus a half. Three halves, right? And then you have cosine 4 theta as well.
Okay, yeah, because you're left with two cosines.
It's cosine squared of 2 theta, so that's 1 plus cosine 2 times 2 theta all over 2.
It's a bit messy.
Oh, but wait a minute. Oh, I forgot the 1/2. Oops. Oops. There's a 1/2 in front of that cosine 4 theta.
Yeah.
Doesn't matter. What's the period of cosine 4 theta? It's 2 pi over 4,
Yeah, I was gonna say, I don't know.
which is pi over 2, isn't it? Are we integrating over a full period?
Yeah, so much smaller. Or 0.
Integrates out to 0 automatically. So we don't have to worry about that third term, because that's going to integrate out to 0. Unfortunately, period of cosine 2 theta is pi. And we're not integrating over a multiple of its full period. So we actually have to do that. Three halves. That integral is just 3 halves times pi over 2, which is 3 pi over 4. And plus cosine 2 theta, right?
What happened to the 2?
You saw. What's the derivative of cosine? What's the derivative of 2 theta? So sine of pi.
It's 0?
Sine of 0.
Is it 1? Oh no, sine of 0 is also 0. Yeah.
That sine of 2 theta goes out to 0. There's your arrow.
Why is the 1/2 cosine 4 theta plus that?
What's the period cosine 4 theta?
0 to pi.
Period. 2 pi divided by 4.
Yeah.
Which is pi over 2.
Um,
You're integrating over a period,
yeah.
which is automatically 0. Sixty-four divided by 16, 4, times 3 is 12. 12 pi minus 2 pi, 10 pi, there's your integral. Now double integrals. So what we're doing is we're integrating the function 4x plus 4y plus 16 over the rectangle 0, 2 cross 0, 2. That cross, do you happen to know what that operation is called?
It's not cross product, is it?
Is it? It's a matrix.
It's an operation from set theory.
Oh,
It's the Cartesian product. That's the definition. Set of all ordered pairs x, y such that x is in A and y is in B.
so I guess you can't take the first product of those.
No, because that's not 0, 2, 0, that's not a vector.
Gotcha.
That's a set. It's an interval, right? It's the set of all x's from 0 to 2. So that is the typical notation of how we write a rectangle. Right? Which, of course, if you look at it, it is the set of all ordered pairs, right? X, Y, where x is between 0 and 2 and y is between 0 and 2. If you sketch it out, that's your rectangle. So that's what we're integrating over. Fubini! Still the best name ever. says we can write it as an iterated integral. And you want to choose an order, dy dx or dx dy. In this case, it doesn't matter which one you choose. Right? So let's go dy dx. Integrate first with respect to y. A little bit of a time saver. X plus 4 altogether, isn't that constant in y? So why not group them together and then integrate? So x plus 4 all times y. And now what is the antiderivative of y with respect to y?
Why would it be times y if you're going from x plus y plus 4?
That's not x plus y, that's x plus 4.
Oh, okay.
Right, so the entire x plus 4 itself is constant in y.
Oh no, I'm talking about in the before you group the x and the 4 together. Because originally you have x plus 4, or x plus y plus 4.
Mhm.
So then why would you go from adding to
So you understand, I group the x plus 4 together, right?
yeah,
What is that antiderivative with respect to y?
just constant. Oh, y.
So you have a constant, let's call it 5.
Mm-hmm.
What is that antiderivative with respect to y?
Oh, just 0.
That's the derivative. What's the antiderivative?
Oh, 5y plus 2.
5 times y. We're going to ignore the constant.
Gotcha.
X plus 4 is that 5. So it's x plus 4
because
times
it's-
y.
Because it's constant.
Yes, because it's a constant.
Okay.
And then y squared over 2, right? And we evaluate that. Y equals 0 to 2. Dx. Uh, 2 minus 0 is 2. 4 minus 0 is 4. All over 2 is 2. So not 6, sorry, x plus 5. You can factor out the 2, you're left with x plus 4 plus 1, which is x plus 5. Now integrate that. And I don't know how much longer I'm going to be writing this intermediate step of x squared over 2, instead of just going x squared over 2 and then evaluating it in my head.
When solving this, could you just write it as one integral and solve that integral and then plug back in, or should you include?
What do you mean?
Like, could you just ignore the 4 integral 0 to 2 and just take the integral of 0 to 2?
You can.
Okay.
Typically, we just do it all together.
Because I think that's where I was getting confused, because I saw that the 4 integral 0 to 2 probably isn't the same.
It's not, it's a different one.
Yeah, now I see where you got it left.
4 over 2 is 2. 2 plus 10 is 12. 12 times 8. Oh, you don't remember your times tables.
Wait.
12 times 8.
Oh my god. 120 minus 24 is 96.
It's 96. Did they make you do that in fourth grade?
Yeah.
Like they did, man, like every day you came in to do a quiz on times
Yeah.
tables, and they wouldn't
Right.
let you, they wouldn't let you advance till you got everything right.
You were given like sheets. You would just solve the sheets.
So annoying. Of course, it was nice when you got the 12s right, because then you didn't have to do it again all the year. What was the first one? Didn't have to work that way.
Shut you.
Here we have a polar rectangle. No, it's not really a polar rectangle, is it now? Polar rectangle would be arc across it. Yeah.
So,
So sorry, this is just a regular rectangle.
for what r equals, is it always going to be the first set of coordinates r for the first
X.
integral? And,
Not necessarily first, but for x. Because you can set the order however you want, either dy dx or dx dy.
gotcha.
But it's always x cross y. Now we have to choose an order. Again, the order doesn't matter. Now if you do dy dx or dx dy, you're going to get the same thing. Again, one's not really more advantageous to do first than the other. I'll just do dy dx. dy first. Then dx. The antiderivative would be sine of x plus y. Now we have to evaluate that. 0 pi over 4 for y. I do not think there's a trig identity to simplify sine of x plus pi over 4. I lied, there is. You can use the sum identity on sine. You can't factor out x. I mean, you can, but it's going to make the result more hideous. Instead of factoring out, just look at those as two separate integrals.
Oh, yeah, because,
Because either way, you're going to have to do integration by parts. The question is, do you want to do integration by parts on what you're going to get if you factor out that x? Or just treat it as two separate integrals and do integration by parts on each one? Up to you. I could also write this, I think, as 3 integrals.
oh, because you could bring the integration.
Yeah, you can do it as 3 integrals. Use the sum identity on sine of x plus pi over 4. You'll get sine x, or for sine of x plus pi over 4, it'll be sine x times cosine of pi over 4 plus cosine x times sine pi over 4. Right, sine pi over 4, cosine pi over 4, they're constants. So then you'd essentially be left with an x sine x, which I can combined to 2x sine x. Well, it wouldn't be, no, because you have root 2. It's root 2 over 2. X sine x. Plus x sine x, so you could still write that, but it would be 2x sine x. But you have an x sine x and an x cosine of x, which would still require integration by parts twice.
So I
So
was gonna say that just sounds nasty. Just sounds like more work to get the same thing. Or to end up doing the same thing.
it just looks nicer because you don't have now sine of x plus 5. So either way, you're going to have to do integration by parts. Once or twice, depending on how you want to set it up. I am going to skip that. I'm not going to do the work for it. Almost giving you a PTSD. Two letters away. We're 3 letters away, depending on how you count it, from giving you PTSD. Using integration by parts. So a lot of algebra, a lot of calculus. That would be the answer. Or just throw it into a calculator, which is I think what I did. Remember, at this stage, I'm not testing if you can integrate.
Yeah.
So I'm not testing your integration techniques.
I'm guessing.
I'm testing if you know what an iterated integral is and how to set up an integral.
Guessing you'd still get points off if you didn't have an answer.
Well, if you didn't have an answer, you had to put those points. Unless it told you not to evaluate.
Well,
Just remember, if the question tells you not to use a calculator, you're not allowed to use a calculator to do the integral. Otherwise, once you get it set up, plug into a calculator.
could you use them to double check?
Oh, you're always allowed to use it to double check. Right, you just can't use it to actually do the work for you. And after we get out of the rectangles, I'm pretty sure I'm not going to do it at all with rectangles. Once we get into the general regions after this, I probably will be using the CAS to evaluate the integrals for me. Because some of them you can just get really wrong in AS to do by hand. And considering the hardest part is the actual setup itself of the integral anyway. Volume of the solid that lies between the rectangle and below the elliptic paraboloid 49 minus x squared minus 3y squared. Volume. Is the integral over your region of the description for the solid. Well, in this case, the solid is above the xy plane. Makes the rectangle 0, 2, 0, 2. And below that elliptic paraboloid. That would then just be the solid that we're integrating. It's technically 49 minus x squared minus 3y squared minus 0. Right? Because this is a volume between two solids. But the one solid, the lower bound, is the xy plane itself, which is just equal to 0. Now we just need to define R, but it was already defined for us. It's a rectangle. Both x and y go 0 to 2, so I think just actually write that out right now. And then decide on an order. Do you want to do dy dx or dx dy? Doesn't matter. I'll stick with the default dy dx. (49 minus x squared altogether is constant in y. Well, the length of the interval 0 to 2 is just 2, isn't it? So that would be your integral. Minus antiderivative of 3y squared is y cubed. 2 cubed minus 0 cubed is 8. Two times 49. 98. Minus 8. There's what we have to integrate. Well, the integral of 90 is just 90 times 2. Two cubed is 8 minus 0 cubed, so that's just 8. 8 times 2 is 16. Times 16 thirds. Right. 2x squared from 0 to 2 is 16 thirds that integral. Yeah, I'm skipping that intermediate step. I'm doing it in my head. Now, what's 180 minus 16 thirds? So it's 180 times 3. What's 18 times 3? Times 10 is 540. 540 minus 16. All over 3. And that can't be simplified, right? 2 and 4 is 6, and 5 is 11, it's not divisible by 3. There's your volume. See that? So far, so good? It's easy, right?
So for the getting 2 times 49 minus x squared minus 8, and where's your y's cancel?
Well, they're not canceling, I'm evaluating. So 49 minus x squared.
But never mind.
I'm skipping that intermediate step.
Yeah.
Yeah, I'm just evaluating it in my head instead of writing it down.
Okay. That makes sense.
Oh, this is so easy so far. You said it's going to be difficult. No, you said multiple integration is really hard. This is easy. It's still rectangular regions. Let's wait till we get to general regions. General Cartesian regions. Let's look at average value next. Still over a rectangle though. I'm going to represent average value this way. So that's the average value of f over r. Remember, that's going to be 1 over the area of the region times the integral of the region of the function, dA. Where our region is a rectangle. What is the area of a rectangle? Not this rectangle, just a general rectangle. What is the area of a rectangle?
Base times width. Radius. Width times length.
I'll take base times width. Length times width.
Yeah.
And what you could call the length of base. So what's the length of this rectangle? What's the length? The length isn't an interval. Length is a value, right?
E.
Okay, you can take length of e. What's the width? 5. Typically, I think that's what you do, right? The length is the x, the width is the y, generally speaking. Until you get into 3 dimensions, then I think depth is x, length is y, and width would be z.
Well, height would be.
Height and width are interchangeable. No, I'm sorry. Width and depth are interchangeable, right? Height is the same. I call it depth instead of width. And so depth is x, length is y, height is z. What is the area then of this rectangle? Which is what? You need to go back to 4th grade to do your times tables again. Do they still go up to 12 in 4th grade? Or do they now go higher?
So, I don't know, I've been in 4th grade a while, so good day.
I was a 4th grade teacher, I'd go higher than 12. I'd make you memorize like up to 100.
Seems silly when you say so.
100's easy.
Well, yeah.
So is any base 10.
Yeah.
Any multiple of 10 is also easy. Which means any multiple of 5 is also easy. Multiples of 3 are also easy. All the multiples are easy in 5.
But then we just need to know 0 from 10. Because it just becomes.
Well, not really. You'd also have to know 11. Because 11 is a prime. You need to know all your primes. Because then multiples of those are easy.
Well, then I guess 0 from
13 is a prime. Unless you know the distribution rule, then you just have to go 0 to 10. So if you know distribution rule, everything else about 10 is easy. If you knew distribution in your head.
12. Just solve it.
So yeah, why stop at 100? We just keep going.
Because you can just
It's about all 4th grade. Just keep going.
just solve that. Whereas these days, I'm sure it's just like what you calculate.
So we have to pick an order. We'll do dy dx or dx dy. I honestly don't think it's going to matter in the long run. But there is definitely an advantageous way.
I was going to do x first because there's already a constant. So maybe the y would be constant.
True. That's actually not the right thing to go first.
Okay.
With respect to y, what's the derivative of x plus e to the y?
It's you with them.
Just e to the y. You saw. Gets rid of that second e to the y right away.
Yeah.
If you do it your way, you're going to have 2 u subs.
Yeah.
Same thing. The e to the y's are still going to cancel. They're just going to have to do it twice instead of
It's
once.
just going to be slightly longer.
So first with respect to y, bound 0 to 5, x bound 0 to 8. I can factor out that 7. 0 to 8. U sub. Right, our function is x plus e to the y. Its partial with respect to y is e to the y dy. Perfect. Let's call it. Now, what is the antiderivative of root u? This one, roll right out. Oh, wait. Sorry, it's not 1/2. Should be 2/3, not 1/2. Bring out that 2/3. 7/60, right? Then what are we left with? X plus e to the 5th to the 3/2 minus x plus 1 to the 3/2, right? X plus e to the 5th to the 3/2. That antiderivative. Two fifths x plus e to the 5th to the 5/2 minus, we're going to have another 2/5, right? And that should be x plus 1 to the 5/2. X goes from 0 to 8. There's a 2/5 common, we can factor it out. It's going to be 5 times 30 in the denominator, 7 over 150. Boy. I hope I have enough room. Probably not. There's the first term. Evaluate it, right? I'm not going to have enough room. Second term. Maybe I'll roll. 9 to the 5/2 minus 1 to the 5/2. What's 9 to the 5/2?
Oh, 9 to.
You should know. It's not that difficult. You know what I'm thinking. What's the square root of 9? What is it? What's 3 to the 5th power?
Is 100. 3 to the 5th.
3 to the 5th. E to 5 cubed. 81 times 3 is what? 243. 9 to the 5/2 is 243. What's 1 to the 5/2? Oh, that took too long. It's 1. 243 minus 1. Later, I'll try.
Dang. Too low.
department. That was the lube. Because next is the ramming. This was like, I guess, a more friendly analogy. This is the shallow end of the pool versus moving into the deep end with sharks and piranha with laser beams attached to their heads.
Mission Impossible.
Sharks with laser beams attached to their heads. It's a different reference. Austin Powers. Oh yes, we're sharks with freaking laser beams attached to their head. It's like, oh, a friend here told me that's not possible. Are they these ill-tempered piranha? Of course. Just start.
We've never seen us. Yeah, I know.
Great. And the third one also. Third one kind of really went. They don't know what. First two, incredible.
They're on the to-do list.
She'll call in me.
I've seen a lot of things. I know the main guys.
That's okay, your group. Sounds like a personal problem.
Yeah. Is it fine if for BE
You have to talk to
me
me.
and my group?
You have to talk to me in that class. You that.
Oh, it's not bad. It's 6 problems.
You got 30 minutes.
Two each. I'll take the first.
So that's going to be less than 30 minutes.
Oh, you haven't even seen what it is.
Oh, yeah, he's like, I got
And then we'll-
I got it.
And then we'll have the 10-minute break, and then we'll start double integration over more general Cartesian regions.
I just kind of wild that they let me do one to the council and then they were like, yeah, no. 'Cause that's why they didn't.
And it was on the council.
Technically.
Not technically, was.
He just wasn't a
He
master.
was on the council, he just wasn't rated the rank of master. And that's because
Yeah.
there are actual requirements to be master. One of them is to train a Padawan to Jedi Honey, which he never did.
Because that's what he was doing with the Sith when 466 happened.
No, Ahsoka left long before 66. She left the order. Because of that bullshit trial.
Oh, yeah, that's right.
So she abandoned the order. A little bit of topology. Two types of regions, type 1, type 2. This is a type 1 region, also known as vertically simple. And you have type 2, also known as horizontally simple. Which brings us into the strong form of Fubini's theorem, which states that any region that is vertically simple or horizontally simple can be expressed, or the integral over any region that is either vertically or horizontally simple can be expressed as an iterated integral. So you can decompose a region. If you decompose any region into two or more non-overlapping regions, except at the boundaries of the region, right, then the integral over the region is the sum of the integrals over the subregions. Right, so this is the equivalent of breaking up your interval. Area of a region is just the integral over that region of the area differential. Average value, 1 over the area of the region times the integral of the function over the region. So a lot of this is a continuation of the rectangular region, if you remember, which is now described for any region in the plane. Right, so this one, again, really important, because now if I ask you to find area of a region, I don't want you to set it up as you would in Calc 1. You have to set it up as a double integral. Evaluate the integral dA over the region in the first quadrant bounded by the semi-cubical parabola y squared equals x cubed and the line y equals x. So let's get in the habit of using a graphing utility to visualize these regions. Some of them you probably won't need to do. Others you will. Now notice what we're being told here. The region is in the first quadrant. X and y both positive. Bounded by two curves. The curve y squared equals x cubed and the curve y equals x. Well, to find the region, don't you need to know points of intersection? And they're not given. So we have to find them. You could tell just by looking at the curves. Or y squared equals x cubed means that y equals what? What is it? Why is it x to the 3x?
Your square root.
True. What's the square root of y squared?
Just one. Oh.
What's the square root of negative 2 squared? What's negative 2 squared? What's the square root of 4? Is 2 equal to negative 2? So it's not y. The absolute value of y. So y is it just x to the 3 halves? Instead of plus or minus.
Because of the absolute value.
Oh, we're looking at the first question.
Hmm?
Are we just in the first one?
First quadrant means y is guaranteed to be positive,
Okay.
which is why it's just x to the 3 halves.
Because that's the word.
If it wasn't just the first quadrant, if y could be negative, you can't do that.
Okay, gotcha.
At which point we probably have to go the other way and try and solve for y by saying that x is y to the 2/3, because that you don't need to worry about plus or minus. So it'd be x to the 3 halves has to equal x. Like if you said y is x to the 3 halves, y equals x. X to the 3 halves equals x. Solve that for x. Again, it's actually fairly straightforward to see the two solutions here. I'll put this in table form, 0, 1. So when I go to plot the region, the two curves where y squared equals x cubed and y equals x. I'm only going to go x 0 to 1. Y 0 to also 1, right? Y equals x. If x goes 0 to 1, y does the exact same thing. There's our region. Now, what I could do if you don't know which curve is which, is instead of doing contour style, the same, I could just pick two colors. I don't know. Red and blue. And then do something not like those legends. You actually don't have to assign two different colors. What you can do is just this. But their colors are hideous. Like those are just ugly looking colors, which is why I generally do not use the default colors. But you can. I'm going to do the same thing. Now what you need to do is you have a good idea of what your region looks like. Is it vertically simple or horizontally simple? So remember, what does it mean vertically simple? Can you describe the region as a region bounded by two curves of the form y equals f1 of x and y equals f2 of x? In other words, can you draw an imaginary vertical bar that slides along the x-axis? Sorry, that was horizontal. Vertical. Can you draw an imaginary vertical bar that slides along the x-axis and its bounds, so remember bounds would be what it's touching, can be written as a function of x? That would be vertically simple. And we can, right? This could be written as a function of x. I already did it. It's x to the 3 halves. This is obviously a function of x. It's x. It's vertically simple. Horizontally simple. Can you draw a horizontal bar that when it slides along the y-axis, its bounds are functions of y? You can, right? This would be y to the 2/3 and y. It's also horizontally simple. It's both. Fubini's theorem says we can write it as an iterated integral. However, we have to decide how do we want to describe the region of integration. Do you want to describe it as a vertically simple region? Because then that would be dy dx. Or do you want to define it as a horizontally simple region? That would be dx dy. Doesn't really matter in this example what we do. Vertically simple is generally the default. Right, vertically simple, type 1, same thing. So that is now the first step of setting up an integral, is to define the region first. We decide to define it vertically simple. I'll actually write out both for this problem, and then in the future we'll just pick one. That means that your vertical bar slides across your x-axis. For this region, what is it sliding over? What's the interval? Well, it starts at 0, and it'll slide up to 1. Those are your bounds for x. As your bar slides from 0 to 1, what is it extending across? What is the lower bound? It's this y curve, right? The y squared equals x cubed. As a function of x, x to the 3 halves. That would be your lower bound for y. What does it extend up to? Your upper bound as a function of x. It's just x. Those are your bounds for your y. There's your description of the region as a vertically simple region. Again, I will this problem only also give you the horizontally simple region. The argument is the same, except instead of a vertical bar, it's a horizontal bar. Now, horizontal bar, what's it sliding across? Slides across the y-axis, right? So what are the bounds? It goes from what? 0 to 1. Those are your bounds for y. As your bar is sliding along that axis, what does it extend from? The lower bound is the blue line. Now you want to write that as a function of y, so it's just y, and it extends to the red curve, y squared equals x cubed, as a function of y to the 2/3. That would be your horizontal description. They are the exact same region, which means these two sets are equal. Which means if you set up your integral with those descriptions, using Houdini's theorem, you're going to get the exact same. That is using the vertical description. Using the horizontal description, it'd be that. Right. Again, I'm writing both out only for this problem just to demonstrate it doesn't matter. And then evaluate. I'm only going to evaluate one of them. Keep in mind, what is this actually calculating? Area of the region, right? Integrate with respect to y, it would just be the upper bound minus the lower bound, right? Now look at this formula. Isn't that your setup in Calc 1? Area between curves? Isn't that how you would set it up in a Calc 1 class? Right? So it's the same thing. Now you gotta get that in your own. X squared over 2. 1 squared minus 0 squared. 1, right? That would be 2/5 x to the 5/2. 1 to the 5/2 is 1. 0 to the 5/2 is 0. That's just 1, right? 1 minus 0, 1 times 2/5. Five minus 4. We have an area of 1/10. See that? A few important notes. If you look back at Houdini's theorem, when you actually evaluate the integral in either case, what kind of value should you get? Constant value, right? You shouldn't get a function. When you evaluate double integral, if you get a function, you did it wrong. You will always get a scalar value. Second, for this problem, the interpretation was an area, right? Can area be negative? So, what should you do if you get a negative out of this evaluation? Redo it, because it means you did it wrong. As long as you did all the math right, your answer should be the absolute value. Generally means that you flipped one of the bounds, right? So maybe you did x to x, x to x to the 3 halves instead. That's the most common mistake. It could also have just been that you completely described the region wrong, in which case it's not even going to be the absolute value, right? But generally speaking, when you get a negative value, it's generally because you wrote the order wrong.
So as long as you set it up right, you're good.
Right, but that's one of these cases where, because you know this is an area, if you get a negative on an exam, you know that it's wrong. You know you did something wrong. You should go back and examine. Right, it's always going to be the wrong description of the region. Generally speaking, not that you evaluated it incorrectly. Right, because you obviously check that negative answer with the calculator, and it gives you negative as well. But that doesn't mean that all double integrals have to be non-negative. In this case, it had to be because it was an area. Same thing with, if it's asking you to find the volume of a region. Can volume be negative? So if you're looking for the volume of a solid, if you get a negative in your calculation, I think you did something wrong. Go back and re-examine. But an integral itself, a double integral itself, can be negative. Double integral is measuring, just like what single integration did. What was single integral geometrically? Do you remember what it was? You're close. So it's not necessarily area below a curve, because that would be infinite, theoretically.
Oh, the area below the curve within the bounds, with the ring on the side?
That could also be infinite.
Yeah. Well, I mean, you could get infinite.
We could, but that's something different. That interpretation is different. An integral is a signed area, specifically the signed area between the curve and the x-axis. Sorry, we don't say below the curve, because that could be infinite, right? Because it would always go on. But if it's bounded by the x-axis as well, now it's not. But it's a signed area, right? Positive if that region is above the x-axis, negative if the region is below the x-axis. Right, that's why we call it a signed area, because now you can get negative. Well, double integral is a signed volume. Right, specifically, it is the volume of the solid between the xy plane and the function. Positive if you're above the xy plane, Negative if it's below the xy plane.
So double integrals will always be no, because
This one wasn't. Because it was an area, that's two-dimensional.
but did you see that it's like volume?
If you're taking the integral function. Are we integrating the function here? It's just dA, right? Which means it's just an area. If it was now double integral of some function f of xy, right now it's a three-dimensional.
Gotcha.
Now it's a sine volume. Again, technically speaking, this is also a sine volume, but the function is a constant 1. But we just interpret it as an area instead. Area between y equals 2x and y equals x squared, lying to the left of x equals 1. And I think there should be something else in here. No, there doesn't need to be. So here's what we're going to do here. Once again, we want to solve, right? Because we want the points of intersection. So we need it to be what? X squared equals 2x. And look at the two values you get. 0 and 2. However, what else did it tell us about the region? Never said that. Didn't say it's in the first quadrant.
Oh, then it's to the left of x.
It's to the left of x equals 1.
Oh, so then,
So we don't need that x equals 2. Right. That tells you it is going to be in the first quadrant.
gotcha. Because it's
Because the first bound is 0. So with all that information comes a plot. Again, I typically just use contour plot. Y equals x squared and y equals x. X is going to go from 0 to 1. I actually want another one in here. I want x equals 1. Now I want to show you what happens. Y is going to go what? Also 0, 1? We used what? Red and blue last time. It's a little weird parent, but let's go fast. Green and purple. Yeah, we probably don't need this because we're pretty familiar with what y equals x and y equals x squared looks like, but just didn't have it. Oh wait, I need a third one. Don't I? I have 3 curves. Which actually isn't pink in Wolfram. Now look what happens. What curve do you not see? because I stopped it at x equals 1. So to make up for that, I'm just going to do something like this. Oh, you bastard, you're still not showing. It's got me not far enough. There we go. Although I really don't need that though, right? Because I'm having it stop right there. Oh, hold on. That's why. Okay. That's not x. That shouldn't be x, right? Which means I should probably get rid of well, I should go up to 2, right? That's better. There we go, that's better. There's our region. Right, so, yes, I'm only going from 0 to 1 on x, but I actually have to go a little bit beyond that when I actually go to plot it, because otherwise contour plot will cut it off. But I don't want to go too far out, right, because I don't want to show more than I really need. Right, if I went out to like 1.5, for instance, it's giving me more than I really need. Now, there's nothing wrong with that. It's just, for my purpose, I just want the region itself. I don't want more than what I need. So that's why I'm going to go out to 1.000, as close as I can get. And yeah, Wolfram says, this is pink. It's like, that's not pink, that's peach. Now, or keep in mind that what the projector is showing is not what the actual color is. It is a peach color. It's more peach. We'll call this pink. It's above my pay grade.
It's a color.
I could get pink by actually looking up the RGB code for pink and typing in the RGB code of the Wolfram. Not really. Here, I'll show you. Colors. There's a website that actually gives you all the codes for different colors. So let's look up pink. I just want regular pink.
Party pink.
You're not going to need just pink.
Some of these are shades of gray. There's literally no way.
That's very pink.
Hot pink is just like a shade can.
Isn't there a way I can get just pink?
Maybe like highlighting pink.
Hot pink?
Hot pink might be the closest.
No, okay, well then guess what? I'm just going to go pink RGB.
That is crazy. That's not pink. That's like purple. Are we finding out that pink doesn't exist?
Can you do like the other RGB code, like the 3 values with the comments and stuff? Yeah, that one.
That's the one
You can just adjust it.
That's the one I'm going for. Oh, actually, no, this is the one I want. And Wolfram. Wolfram wants it to be 0 to 1. What I would do is I would just divide each of these by 256. But no, I don't want that. I'm going to go with this one.
Have you ever seen a video of a dude that like has memorized RGBs because he was like a coder or something like that, and he had to he was doing like video game stuff, and he had to like texture code a bunch of things, and he needed specific RGBs. So he has like he does a video where he's like given an object, and he's like find what the RGB is, and it's like
So there you go.
he's able to get it within like a couple shades, like 2 or 3 shades.
Yeah, see, that's big.
Yeah, that's better.
Yeah, that's better.
So there, I'm using that because that's like the only complaint I actually have about Wolfram is that one of my favorite colors is rarely F's up.
Got purple with it.
I'm just wondering if it's like set up the same way as like other sets. If you put a fourth value after that color, does it change like the opacity?
There's a way to do that.
Okay.
It's called opacity. But no. But you can also do CMYK.
Okay.
You can also do CMYK color. Same thing. And it has to be between 0 and 1.
Right.
For each one, then you have 4. Right. I find RGB easier. Because I actually don't know what you divide by CMYK. Is it also 256? I don't know.
I'm not sure.
So if it gave it to you without the decimals, I don't know what you divide each one by. I know RGB is, the scores are 0 to 256. I don't know what CMYK is. I could look it up, but it'd be the same thing. It has to be between 0 and 1, so you have to divide each one by whatever the maximum value is to get the proper ratio.
Yeah, I can tell you. I don't use RGB enough to
CMYK.
see.
Yeah, I don't use it. Even though that's what all the printers use. So the region we want is bounded by all those curves, right? So again, you have to decide, do you want this to be described as vertical or horizontal?
In this case, probably vertical because you want to be around.
And it doesn't matter which one you do. But you bring up a good point.
I guess it's easier to
Look what happens if you do horizontal. You're going 0 to 2. But right at that point, you're down switch. Which means this region, if you're doing horizontal, is actually the intersection of 2 non-overlapping regions.
Is it 2 double one?
You have to set up 1, right? You divide it right here. You set up 1 for that lower region and 1 for the upper region. Whereas if you do vertical, notice you only have a single region that you have to worry about. So that's how we're going to do it. But yet, it doesn't matter which one you do. You're going to get the same answer.
Just depends on how it's
Right, so you want to do whichever one is most convenient, generally speaking.
or if you're
Unless I'm being a particular prick that day and I go, no, you have to do it this specific way. And make it so there's like 8 regions that you have to go over. X goes 0 to 1. Y goes from what to what? I would also argue that's probably not green. It's like lime green. It's not the actual green color itself, so we'll screw that one up too. But
it's a shade of green.
yeah, but it's not green. So we'll screw that one up too.
It's more green.
I'm not going to fit. I'm not going to go back and fix it. The peach is a shade pink.
Yeah. But it's more like one.
So if I'm gonna hold Wolfram to that standard, then I also have to criticize it.
Yeah, but the fruit peach is like orange. Oh, semantics.
So what are the bounds for Y?
0, 2.
Oh,
wait.
Y of two. And
No, it has to be a function of X.
It's x is x squared plus 3. Y is
And so again, remember, draw your vertical bar, slide it. What's the bottom, what's the top? X squared to 2x. There's the setup that I want for this class. The dA of the y dx. And you wouldn't set this up as a calc 1 integral. I want to say it's set up as a double.
I feel like this is easier.
yes.
No, it's not.
With calculus.
No, it's not, because now I evaluate that.
It just becomes 2x minus x squared.
Which is exactly what you get in calc 1.
Oh, no, I feel like this I see.
Right, remember calc 1, 0, it's integral 0 to 1 of upper minus lower, which would be 2x minus x squared.
In this case, though, I feel like it's more easily defined as what's upper and lower. Because sometimes in calculus, it's not very
It seems that because I'm now actually describing the types of regions and how to actually visualize them.
yeah.
But the argument's the same even in calc 1.
Yeah, I get what you're saying.
So that's x squared, right? 0 to 1 is just 1. X cubed over 3 from 0 to 1 is a third. You get 2/3.
I guess it's only easier if you don't have a function. If you had a function.
You're talking about the actual setup.
Yeah, of like getting into this and whatever. Because if you had a function, it wouldn't just be. It would still be.
The description is still the
It
same.
would still be upper minus lower, but.
Well, it wouldn't be if you're evaluating a function because you have to actually integrate the function.
Right, that's what I'm saying.
But how you set it up, the bounds is exactly the same.
Saying it'd be more work.
Right.
So it wouldn't be.
And actually speaking of that,
For X.
yeah, it's going to be job received.
I didn't ask that.
Well, it is.
No. Your Honor, no.
Okay, evaluate. Where D is the region in the first quadrant, so that's important. Bounded by the hyperbola xy equals 16, and the lines y equals x, y equals 0, and x equals 8. Again, get in the habit of plotting these down. Now, for these types of regions, you actually can do this on your TI and spot. Just go to graph, switch your entry mode to relation instead. And you can plot these lines. I'm going to jump to this first. X times y equals 16. y equals x, y equals 0, and x equals 8. I'm just going to let Wolfram choose the colors here because I don't feel like going through 4 different colors. X goes from 0 to 8. However, I want to extend it out just a little bit because I have x equals 8 as one of my curves, right? Y is going to go from 0 to something. Also 8, it looks like.
Shouldn't it also be 8 because we're going by y equals 6? Is that squared?
Yes, but if x times y equals 16 goes above 8,
Okay.
I need to account for that, but it doesn't. Right, if x goes from 0 to 8, x times y would mean y goes from 0 to 2.
Oh.
No, I'm sorry. 2 to 16 over here. That's a problem. I'm just going to go to 8. But again, I have y equals 0 as one of my curves. So I'll go a little bit below. That looks good. I theoretically should have actually found points of intersection. But from here we can kind of see we're not, I mean, we're going to kind of need them, I guess. So what I'll do here is I'll go ahead and copy this image. Here. Like so. And what I want you to do is first determine the region, determine where it is, and second, describe the region. You can choose either vertical or horizontal, because this is where we'll pick up on Wednesday. So there's your homework. You have to first pick what region we're actually integrating over, and then describe that region. Either vertically or horizontally, it doesn't matter. And I will post these slides right after class. So I do want to bring this up. Ninth homework, ranks up there. Third group assignment is up. That will be due the end of July.
Wasn't that more? Yeah, it was like, when I was submitting the second group assignment this morning, it looked like the third group assignment was more just due for today.
Message me, I'll take a look. It will be due 30. So it's possible the date didn't update. I forgot to update it.
Because I looked at that and I was like, oh,
Yeah, that's incorrect. If that's what it is, then that's wrong. I'll just look into it. Fourth quiz will be after class on July 21st, which is next Monday.
I feel so far away. Same July 20th.
Second exam bonus is up. Will be due the 23rd of July, same as before, right? Extra up to an extra 6 points. The second exam will be on the 23rd. That's next Wednesday. It'll be the first 100 minutes, just like the first exam. 10-minute break, and then we'll start new stuff.
Does the testing center notify you if?
No, they don't send me any notifications
I don't know that sure.
because they're weird.
Yeah, the one, because I know the one at Rome does.
They do.
Which is.
Yeah, they don't. Because the one at Rome, they actually require to have equipment first. And then I submit it.
Here they do.
They don't require for me to submit the
You can
exam.
submit it whenever.
At Rome, that's actually required, they're already the appointment before I submit the exam.
It's so strange that they don't do that here.
But yes, they won't notify me when you're appointed, so they don't notify me when a student makes an appointment. Which is weird, stupid, but, you know, but I have the exam and I plan on dropping off Wednesday with the DE exam as well.
Wow, people. I mean,
Right, so again,
people making it harder to use accommodation.
You will-
Crazy.
we'll start on Wednesday with coming up with a description of this region. See you then?
And you said the extra credit is already on?
Yes, it's up there. It was added to this week's at the bottom.